Okay, hey everyone, welcome for those of you who hopefully you are here for this Leetcode thing. So we will get started with that shortly. I'll just give like a quick intro blurb, and then we can get started, and then we'll take it up. This is like a super informal like thing. Uh, so um, yeah, so we want to try to make this like a regular thing, but you know, we don't want to like make it too elaborate just because it's a lot of work to set up. So there's like a after event survey. So our idea is to like just get this rolling, right after the info session, see how it goes, get you guys' feedback, and then next week we'll hopefully do another one, and we'll try to incorporate your changes so that it's better. So, is everyone familiar with like what Leetcode is? I'll give like, okay, I'm not seeing any like confused looks. So I'll give like a one sentence description just in case there are confused people. What Leetcode is basically like programming puzzles. Usually it's very similar to like an assignment you might do for like a programming class. And usually they're asking you to like think of like a specific problem and provide code to solve it. A good example might be you are receiving a sentence and you're seeing if there's like a palindrome in it, or you're receiving two numbers and you want to add them together without there being an overflow. So like they're pretty small problems. They definitely range in like the difficulty and like how elaborate they are. And they are often used in interviews. So might be a reason why you're interested in like practicing Leetcode questions, because you might get asked to solve one in an interview. And the reason why they ask you to solve one is just to kind of see where your programming ability is at, but mostly also how well you are with like problem solving. So in a perfect world, you're given a problem that you might have not seen before, and then you will talk through your thinking to the interviewer, and that will kind of gauge where you're at. So of course, sometimes people just try to memorize the solutions before, but don't do that. Okay, so we have 4 questions for today. So the first problem we're doing is removing duplicates from a sorted array. So what the situation is that you're given an array, and that array has integers in it, or like whole numbers basically, and they are sorted in a non-decreasing order. So in other words, they're sorted in an increasing order, which I do not know why they worded it like that. What you want to do is remove the duplicates in place, meaning that in my example, I'm using Python. We have that parameter nums. Oh, good click. Nums, we're going to be modifying that like in our function. And then the test code will see that. So you're not creating a new array. Don't do that. What you are returning, though, is an integer of the number of unique elements. So basically, you're going to be doing something to nums. You're going to remove the duplicates. And then afterwards, you're going to be saying, returning an integer. And that integer is reflecting like what the size is. So let's see with the very first example. You're given 1, 1, and a 2. So that's your input. What you're going to do is you're going to modify that nums in place so that it just contains 1 and 2. They even have like a little dash, so you could technically put it at the end. But so yeah, so you're modifying nums in place to just be 1, 2, and then your actual return value is a 2. So hopefully that makes sense. If you haven't used Leetcode before, on the right-hand side, after you sign in, you can like choose whatever language you want to use. So I feel like a lot of you folks probably do C#, and there's also JavaScript and TypeScript. It's C if you're insane. But yeah, you can use whatever language. I'm going to be using Python. I'm going to try to make it in a way that's not like super, you know how like Python has that weird syntax that you can dive into. I will try to make it general enough so that we can all understand. But if there's no questions on the chat here or in person, I will go ahead and start the timer for 5 minutes, and then we can take it up. Cool. Make sense? Nice. I'm seeing a lot of people already working, so I'm assuming we are good to go. But if you have any questions, please come up and tell me. Okay, I'm gonna go ahead and take it up. Feel free to keep working if you're like super close or whatever. But otherwise, listen to my beautiful voice, and I will tell you what I would do. So I first need to get my mouse here. So we know that the problem is giving us a sorted, like a pre-sorted array of numbers, and then we have to remove the duplicates. I don't have the problem description up here, but one of the things I noticed is that that whole thing about being sorted, that was in bold, and that's kind of like a good hint. And Leetcode will be pretty good at bolding what you need to pay attention to. So what we know is that if the array is sorted and there's possibly duplicates, well, those duplicates will have to be next to each other. So what we want to do is go through the array and then look at an element and then look at the elements next to it. And if it's the same thing, then we know we found a duplicate and we can get rid of it. But if it's a different like number, then we know it's not a duplicate. Enough talking. I'll get started. So the first thing I know is that I'm returning an integer. So what I like to do with these kinds of problems is always like initialize or like think about what I need to return. And I would just call it results because I'm boring. So we know we have a result, and that's going to be the unique size, and we'll just set that to 0 for now. And there's probably a good way to like iterate or like go through the array. But when I'm first solving a Leetcode problem, and I know I need to like use some sort of loop, I'll use the most basic loop there is, which is just while true. Oops, you have to spell it right though. True. So basically, this loop's going to go on forever. And what I'll be careful to do is find the situation where it shouldn't be going, and then break out of that. And in this case, we know that the array is or the loop is done once you reach the end of the array. So we'll keep that in mind. Now that we're in our loop, what I like to do is think of like each possible condition that could be happening in that loop, and it's each possible condition that relates to whether the loop should continue or not. So in this case, we want to return a size of the final array, and we're in this loop, and we have this variable called result, which is the final size. So those three pieces kind of go together. So what I need to do is just think about what result is going to be on each iteration and go from there. And what I like to do is start from the most specific kind of situations to the most broad. So we initialize results to 0. So we know that at some point results will be 0 in that loop. So I think about what I would do there. So if result equals 0, if result equals 0, we know we've just started the array. I should backtrack a bit and say that like we're going to also use this result as like an index of what the that makes sense. Yeah, of what the array will be. So if it's 0, we know we just started this loop, and so we know we want to do result equals result plus 1, and we know we want to continue. Okay, so we've thought about that case. What's another case? Well, another case could be that this result has reached all the way to the end, right? So you see, like I'm still thinking of very specific situations. So else if the result, I'm going to use a bit of Python shenanigans, but even though I said I wouldn't, but if the result is equal to the length of the numbers, we know we've just reached, I mean, maybe the most correct way to do is this. But if it's equal to the size of our numbers array, we know we've reached the end. Like we shouldn't be doing anything because otherwise we'll be indexing like something that doesn't exist in the array, right? Remember that arrays start on index 0. So the size of the array as a number is the last index plus 1, I believe. Yes. So that's a good thing to know. So in this very specific situation, we will want a break, and that break will take us out of the loop and we'll be ready to return our result. But we're not done yet. Another situation that's pretty specific is that our number at the results is equals to the numbers at the results minus 1. So this is kind of the meat and potatoes of our solution. You want to say that, like, hey, if the number we're looking at is equal to the number previous, then we found a duplicate. Again, I'm going to use a bit of Python stuff, but it really to just kind of make it like clear and concise. So in this case, we want to remove the duplicate. So there's a nice function called pop, and we can do pop at the results. And what that will do is modify that numbers array in place to get rid of whatever's at the result or at the index, which is the result. And so that's our work. And I'll just continue after this. You'll notice that I didn't set results, like I didn't increment result. I didn't say result equals result plus 1. That's because when we remove an element at results, then results will then point to a different element, right? Like if I had like 5 baskets of things and they're in like a nice order, and I went out and I took and I say my number is 3, and so I go to the 3rd basket and I take it out, and then my number is still 3. In that resulting set of baskets, which is now 4 because we removed one, if I went to the 3rd one, that's a totally different basket and we know that because we just removed one, right? So whatever we pick in that set of 4 baskets is going to be different than we looked at before. So that's why we're just leaving that as the same. Lastly, we'll do a nice else. I always suggest like getting to an else, even though we could have probably put this as like an else if I guess it's not equals to the element previously, but it's nice to like have a catch-all. Even if your solution is wrong, usually your solution will be wrong at that catch-all because it's much more broad, right? Like, remember I was saying that when I solve these, I go from the most specific situation to the most broad. Say my solution is wrong, which hopefully it's not. If Leetcode comes back and says, oh, like whatever, you failed these test cases, my hunch would be that it's something around here. Like maybe I need another else if or something like that, because it's like a much more, like, it's much more likely for the code to fail in that way. However, I'm pretty confident, and we'll see in a second, that we're good. So otherwise, if it's not the very first element, if it's not at the very end, and if it's not the same element or the same number as the one before, then we kind of just do the most boring thing, which is just do results equals result plus 1. And we can put a continue here, even though it's kind of, it doesn't really do much, but I like it because it's nice and neat. And that should be good. We just have to remember what we want to do with this function. Step 1 was to modify numbers in place. And we do have a spot in there on line 12, I think, to pop stuff out of it. And the last thing is we want to return the final size. And that final size will be results. So we can just return results. And so, yeah, when I'm really when I'm coding in general, like all of my return variables are always called results, only because you can't use return because that's already a thing in most programming languages. So I just use the next closest, which is result, which is nice and boring, but I think that's good. So now that I've put a solution, I can hit play, and that will just test it against a few cases. I don't know where this thing went. Yay, so it's accepted. So we can see down on the bottom right that the two kind of example test cases is fine. But we're not done yet. We will want to hit submit, which is going to test it against all of the like 700 test cases or whatever that Leetcode has. And we'll see what happens. And we are good. You'll notice it's very slow. That's totally fine. Someone online had a solution involving a set, which I would imagine is going to be a lot faster. But that's fine. Sometimes, like I know a problem I have, and I think it's a common problem, is to try to like over-optimize before like just getting a solution. I think once you have a solution, then it's easier to make that faster than trying to just create a fast solution from the get-go. And when you're in like an interview situation, boring is best, because even if you end up not solving it or it's incorrect, if you have a boring solution, then chances are your interviewer at least understands what you're trying to do, instead of like, oh, I'm just gonna like try this really fancy solution, and if that doesn't work, then like you don't really have much else to lean on. You really just have to cater to the lowest common denominator. So yeah, so that was the very first solution, or very first Leetcode thing. We'll move on to one that's maybe a little harder. And then it's going to be the same pattern. I'll give 5 minutes, check in, maybe another 5 minutes, and then we'll take it up. All right, after some struggles, I got to the next problem. This problem is called 66. So I'll put that in the Discord and chat and whatever, and then I'll talk about it. So this is problem 66, and it's called +1, I guess. And I will describe it in a second. So +1 is you're given a large integer, but that integer is represented as an array. So this kind of setup is pretty common, where you have you want to do something with a big number, but instead of just giving you the number, they're going to give you an array where each element in the array is a single digit. So you're given an array digits where any element at the ith index is the ith digit of the integer. The digits are ordered from most significant to least significant. So basically just like a normal, I don't know why they describe it like this, but just like it's described normally. So if you have the number 1, 2, 3, you will get an array 1, 2, 3. And what you want to do is increment this large integer by 1, and then return the resulting array of digits. So you get an array and you're returning an array. You don't need to worry about the length of it or anything, but you just add 1 to it and see what happens. And just for fun, does anyone know why we might represent a big number as an array rather than just normally? It's a weird question. It's sometimes used in like security or like operating systems. I think Python actually does it under the hood. And the reason is because if you have too big of a number, it'll like overflow. So like, say like you have a 4-byte integer and you get to like however many billion, whatever. If you try to increment that, it'll like loop around basically, and it'll become like negative so and so and so and so. So what we do instead is just use a big array, because we know that same problem is not going to happen. It's definitely a lot slower and like less efficient, but yeah, that's why we use an array. But that's completely unrelated to this actual problem. But yeah, I'm just going to check the chat here. Yes. Oh, someone asked for the solution. I'm going to do two things. This session is recorded, so there'll be a YouTube video that's like hopefully edited for the highlights. And in that YouTube video, I'll put the code that I use for the solution. But keep in mind, it is Python, so but hopefully not too hard. But anyways, I'll get that started and then respond to this person. So yeah, 5 minutes, and then I'll take it up again. Okay, it's been another 5 minutes. I know this one's actually kind of a trickier one, but just in the interest of time, I'll just take it up quick. So the problem is we get this array of numbers. In Python, they call it a list, but it's basically an array. And you want to add 1 to it, which is a pretty easy problem, right? Like if you get like an array of just the number 1, then you just add 1 to it and you're fine. However, there is that fun case where what if one of those digits is a 9? You will still want to add 1 to it, but then you have to like add another 1 to the previous digit. And so that's where the tricky bits come, or the tricky part of this problem is. So I'll go through my solution. Probably there's others, but this is like I try to make this one like long so that it's like very clear what it's trying to do. But obviously when we hit submit, it's probably going to tell me I'm very slow. So anyways, we talked about like the situation where if one of the digits is 9, then we have to like add 1 to the previous one, right? So in math, they call it a remainder. In my notes, I called it a carryover, but I'm not really good with math terms. But anyways, so that situation where we have a 9, that's kind of like a true false, right? So we want to have some Boolean that tells us, hey, like we have a 9 here. So in my code, I call it has carryover. And I'll set it to false initially because maybe by default it's not true. We got to check first. And then we want to add, 1 to the previous number and so forth. At the end, though, we want to deal with this carryover, right? Like we don't want to like add 1 and then get through our code, whatever that is, and then at the end there's still this flag that says, hey, you still have this carryover to worry about. So I will just go ahead right now and put this thing called an assert, which is basically saying if, so we want to assert that has carryover equals false. Otherwise, you did not think of the carryover. And we'll see more about why I put that in later. The general idea is that it's not really part of the solution at all. It's just something for me to be like, did I think about the things that I said I was? Now we are more ready to start our code, but at this stage, I still would probably start with like a rough idea of what I want to do. And the way I came up with was to start at the last digit, and the problem is called add 1, so we want to add 1 to that. And then we want to go through the rest of the digits. And in this case, I would say we want to go through the rest of the digits backwards, because if that final digit was a 9 and we increment it, it's now a 0 with a 10, but we have that carryover. Then we want to we would say propagate that carryover backwards. So if you got like the number 111999, we go to the very last digit, which is a 9. We make that a 0, and then we got to propagate that carryover backwards until we get to a situation where we can safely add 1 without it, becoming a 10 or whatever. So that's my basic plan. So let's fill this in. So we want to start at the last digit. Python gives you this very convenient thing where if you give it an index of -1, it just goes like loops backwards and then gives you the last thing. But most programming languages, besides like C, will give you some convenient way of getting the last element. If it doesn't, you can just find the length and then use the length -1. But I did not do that, which maybe I should. So it's like the last problem, we're going to be thinking of the last digit. And for me personally, I just go from the most specific case to the most general. So in this case, the most specific case, and the problem I know in my head is that, oh, if that last digit is a 9, then we're in trouble. So that's what I'll think about first. So if the last digits, which is our thing, and I'm just indexing -1, but again, that's just the last element. If that is a 9, then we know two things. One, it needs to be a 0 now. We can't just add 1 because that would be 10, right? And that would kind of break everything. So we want to set it to a 0, right? Like that's how we would do math. And then we would say that has carryover is equal to true. And my screen is extremely small, so I'm just hoping I'm writing that right. So okay, we thought of our like most stressful situation, which is the 9. The next situation is a less stressful situation, which is that it's not a 9. And really the last digit would be less than 9, hopefully. And just to be safe, we would say it's greater than or equal to 0, right? So this probably will always happen, right? Like it's either a 9 or it's between 0 and 8. But I'm just being, again, moving from most specific to least specific. And in that case, we're safe, right? If it's less than 9, then we can add 1 to it and it won't become a 10 or anything. So that, for some reason, Python does not have that ++ thing, which I do like. But cool, that's our like a bit more broad of a situation, but still good. Even though I'm pretty confident these two conditions it will either be one or the other, I'm still going to be putting an else here because if I'm not expecting anything to happen here, right? Like I'm not expecting a digit to be like -0 or -5 or 13 or anything. But just to be safe, I'll do something which is a raise, which is basically just it's like a throw. It's like cause an error, cause a fuss. And in Python, yeah, I would say, I don't know what the best way. Okay, I'm going to use a thing called f-strings, but basically what I want to say is that the digit is unexpected. An f-string basically just lets you like interpolate or like put in the thing. But basically I'm saying like I'm using f-string just so that I can know what the digit is. But really like any sort of error message would be good because it's just telling you that like, hey, like you messed up, right? Like maybe your assumption was wrong or whatever. And in like a job setting, having something like this is great because even though your boss or like team lead or something is saying, hey, here's the situation, maybe they're wrong, right? And so you can be that person, even if you use code like this where it just causes an error, even though it goes to like production and then it breaks and it crashes and everyone's stressed, at least you have a very nice error message that you can be like, I know exactly what line that error occurred. It's not like in a terrible case where the code runs without an error, but it's like doing something that we never thought would happen. And that's actually like the worst case is when it doesn't crash because there's a problem, but the program is not telling us there's a problem. But anyways, that's a minor tangent. Okay, so we thought about that last digit, and it's either going to be a 9 or it's not, and hopefully it's not like -5. But in any case, now we need to think about the rest of the digits. So we want to go backwards, and as long as we still have this carryover thing, we need to be incrementing things by 1 as well. For example, if it's 1999, the last digit becomes a 0, and then we want to add 1 to the 9 before it, but so that will become a 0. But then you have to do the same thing, right? So it's trickling backwards. So you first want to know where to start at. Python doesn't really, or maybe it does, but Python doesn't, that I know of, give you a very easy way of iterating backwards in the way that I want to. So I'm just going to use this variable I, and I'm going to set it to the length of digits, which is going to get me roughly to the end. But remember that the length is the last index plus 1. So we want to subtract 1, but then we also want to subtract another 1 because we want to start at the second last digit, not the last digit. So in this case, we're going to do -2, and that's the digit right before the last one. And also, we want to have a loop, right? Because we want to loop through all the other digits and increment them by 1 if we need to. So there's two things, right? We want to go backwards if we need to. So we need to if there's a carryover. And we can only keep going backwards if I is greater than or equal to 0, right? Because if I is -1, then that's the -1 index. And that actually in Python, that would cause a lot of issues because they will go all over the place. But in like a theory point of view, we want to go to the very start of our number. So let's get started. So in our loop, again, we're going to just think about the most specific case to the least specific case. And in this case, if the digits at I, right, so starting at the second last number, if that is 9, well, we're doing a very similar thing to the above. And I almost, when I was working on this last night, I was actually copied and pasted the code from above, but there's actually a small difference, and we'll see that in a second. So the digits at I is 0, right? That makes sense. Yet 199, last digit becomes 0, second last digit becomes a 0. And in that case, we're still pretty happy because we'll just keep going. So that's a very specific case. Again, I'm thinking of the most like stressful thing, which is if it's a 9. But otherwise, another situation is just like above. If it's less than 9 and digits I is greater than or equal to 0. So this is very similar to the above. However, in this case, we are actually kind of happy now because we know that our carryover problems have ended because we've reached a number that can be safely incremented by 1 without there being problems. So in that case, we can do digits I equals digits I plus 1. So we do our increment, and now we can set our carryover equals to false. And hopefully we can see why at the end we have this assert to make sure carryover is false. That's just for me because at some point it has to be false. And just like above, I will put a final catch-all being like, hey, oops, I could spell, phrase, no, digit is unexpected loop. I would just say, I won't bother with the fancy rest. But if I know if I get this kind of error message, I know exactly where to go. And I tried, I didn't do the best job because it's Leetcode, but I try to make the error message different as well. Because again, if there's a crash, I want to know if it's this error or if it's the one above, right? I don't want to make it the same error message. And then the last thing is I do need to decrease I because by 1, or else it's just going to be looking at the same index all the time. Unfortunately, Python doesn't have the same kind of for loops that you would see in like C or C++. They use range-based for loops, which more like it's generally very nice, but I find with Leetcode, it's the only annoyance I have with Python and Leetcode. So cool. So we've we've incremented our very last digit. We thought about whether it's a 9 or not. We're then moving backwards. And hopefully we're reaching the situation where the carryover is false. Sorry, my mouse is on the wrong spot. And so we set the carryover to false. However, remember in our loop, there's two things. There's that it goes if there is a carryover, and it goes also if I is equal to or greater than 0. So there's a possibility that we get to the very, very, very start of our number, and we still have this carryover problem, right? And in that situation, it's when you have like 99999, right? You've incremented the last one, you've tried to go backwards through the whole array, and you've incremented each one, but you're still left with this as carryover equals true. And if I would try to just run this program, if I can find my mouse, really bad at this. If I just try to run this, we might get this error, right? So again, very helpful error, and it kind of is helpful just being there because I see it looming over me, and I just know that I need to think of it. So if in that case there's a has carryover, I can't spell has carryover, and I would say like and I is less than or equal to 0, just to be safe. I know in that case we need to add a 1 to the start of our number, right? So if you try to increment 9, that becomes, in this array format, it'll become 1, 0. So that is what we will do. We will say the digits, which is our result, it'll equals an array of just 1 plus digits. This is kind of like a fancy way to do it. So Python you can just add arrays together, and it concatenates them, very similar to a string. I think in most languages you will have that. Otherwise, you will have a function called like append or something like that. And just to keep my little assert happy, I'll say it has carried over equals false. So if all works well, I'll just check the chat in case it's digits -1. Is there a digits -1 in my code? Someone told me it is a typo. And so the digits, the one up here has to be -1. I'm just going to run it because I really can't see that well. But yeah, if there's an error, oh, oh my gosh, what's going on? Oh, you know what? So Python is like pretty specific on your indenting. But I'm just going to make sure. Sometimes I just spam them run, so it works. Oh, you know what? People are just messaging in the chat. Line 10. Line 10 has a problem. In the worst case, I do have a solution. Is that? Oh. Oh, yeah, there's 2 pluses. Sorry, I cannot see my mouse also. Yeah, no, I see that error message, but I'm looking at line 10 and there is 2 pluses. Yeah, exactly. But it's good that we have that. Well, I mean, in this case, the error message was kind of nonsensical, but oh, there's 2 rays. Oh, okay, I see what you're trying to tell me. Sorry, it's something about presenting that just makes me not able to know. Something, happiness. Yay, finally. I'm sorry, guys. Okay, then I'll go to submit. So we did our solution. Hopefully that makes sense. And you can see, oh, actually I was not the slowest. As long as I'm like not like the upper range, and I'm happy. But yeah, so that was the solution. The speed also depends on like, I think when you try it, because if the servers are overloaded, then it's probably going to be slower. That's what I just told myself. My solution is slow. But yeah, that was the second problem. Definitely a little longer. But I hope you see like the same pattern of like, you think about like what will be the problem cases. Like I'm pretty sure everyone thought, okay, if there's a 9, then we're in trouble. So you take care of the 9, and then you think about a little bit less, specific situation. And then in this case, it was helpful to also put like a catch-all to be like, hey, if we end up in this situation, then we're in trouble. Okay, so I'm mindful of the time. The next problem is a lot easier, I would think. So in this case, I'll just give the 5 minutes and then take it up, just because the solution is actually very easy if you know like the trick it has. So let's start with that. So this last problem is called contains duplicates. Hopefully it's sharing. So I'll do the whole thing with the URL. And thank you, chat again, and people for telling me what's the issue. So yeah, in the general channel in Discord and in the GDSC or the GDG meeting thing, there's the link. But if you're not part of any of those, what problem is it? It's problem 217. Is that cut off for people? Did I just notice that? Okay, well, let 217 and then it'll be good. So I'll quickly explain it and then give 5 minutes. So this one is very similar to the very first problem. You're given an integer array of numbers and you're just returning true, so like a Boolean true, if any of the values appears twice, and false if they're all distinct. So the only thing, just as like a hint, unlike the first problem, this is not sorted, so you can't just rely on that. But otherwise, hopefully it's an easy problem, and I'll give 5 minutes on the clock. Okay, it's been 5 minutes. Normally I would ask if people want extra time, but just because I'm realizing we're coming to the end, I'm just going to take it up. But also, the solution is kind of just, it kind of is like, if you know, you know. That's the best way to describe it. So the problem is we are given this array of stuff, and we want to know if it has a duplicate or not. So one thing that's nice is that since it's a true or false return value, there's, as soon as we find a duplicate, then we're safe, and we can just return true. Otherwise, if there's no duplicate, you can imagine that we're going through the whole array and checking if there's a duplicate. And if we get all the way to the end and we haven't found any duplicates, then we return false. So what is the trick? The trick is to use what we know about data structures, which I realize that this might not be a topic that you've been taught yet. You probably will hear about it in the upper year stuff. But the idea with data structures is that you can think of it as like there's common patterns of like coding, like arrays or strings or that kind of stuff. And they're so common that we call them data structures. And a lot of languages will provide you like built-in data structures, like pre-coded, just to make your life easier, so that you're not like reinventing the wheel each time. And the data structure that's relevant here is one that's called a set, which is similar to like a hash set or a hash map or dictionary. Those are all kind of in the same family of data structures. And a set is almost exactly the same as like a mathematical set, which is a mathematical set. I'm terrible at math, so I might be completely wrong. But my understanding is like mathematical set is like a collection of distinct items in it. So that's like the prelude. I'll go into the demonstration. So we want to use a set, and what a set lets you do is contain unique items in it. So you can't have duplicate items in it. So in this case, it's very handy because it already doesn't contain duplicates. And the other nice thing about the set is that you can easily check if there's something in it. So with like an array, if you want to know if something's in the array, you have to like go through the whole array to check for that thing. With a set, we say it has like an order one or like a fast lookup time. So basically I can say, hey, does the set have this item? And it'll be like yes or no. It's similar to if you know what a dictionary is. I think dictionary is sometimes a little bit more common. A dictionary is very similar, like you can't store duplicates. The only difference between a dictionary and a set is that a dictionary is not just like a collection of things. It's kind of like a phone book. Like you look up stuff in it, or it's like a real life dictionary, right? You can look up a word and then it'll give you the definition, which is related to the word, but it's like, they're like they're associated data. A set would be like a dictionary that just contains the words and no definitions. But anyways, I'm just rambling. So I'll have this variable called contents, and because I'm using Python, it just gives me things for free. But most languages outside of like C and C++ will have some sort of equivalent. Python, we just have a thing called a set, and so we'll create a set. And now we want to do the thing that I just described in the very beginning, which is go through our whole array and see if there's a duplicate. And if there is, we return true. And otherwise, if we get through the whole array and we don't find a duplicate, then we can return false. So in Python, we can go through the array like this, or in nums. In other languages, you might do like for I equals 0, blah, 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 up until the last number, last index or whatever. But Python makes it pretty easy. And because we have this convenient set thing, we can just check. So this set is initialized with like nothing, so it's going to be empty at first. But even still, we can say, hey, if our n, which is an element in our number array, if that is in our num contents, then we have found a duplicate. So we can return true, which makes some sense until you realize that like, hey, num contents has nothing in it. And like, it will never have anything in it unless we do something. So if n is not in num contents, then what we want to do is add it to it, which num contents has this nice function called add, and we can give it n. So basically, we're still kind of using the same pattern. Think of the most specific situation to the most broad. The tricky part here is that it's kind of, it kind of makes sense as a whole. It's kind of hard to like think of it sequentially because you want to add stuff to the set and then also check in the set. But it's the same idea. We go through each number and then we use our helper set and say, hey, does our number already exist in this box, basically? And if so, we know there's a duplicate. Otherwise, if it's not in this box already, put it in, because then I want to go to the next number and then do the same process. So they both kind of support each other. So that is the function, and that function will work if there is a duplicate. However, if we get through this whole for loop, and that little, I call it like a short circuit, that little return true never triggers, that means we always had a situation where there wasn't a duplicate found. So we know here that we can just return false. And this kind of pattern is actually, you'll see it more than once, because there's always like a situation where you want to go through a box of things and then do stuff and then return true if what you're searching for happens, or otherwise you go through the whole thing and return false. One example is like if you're checking if an array is sorted already, you can go through it and check if like each pair of items is like in an order, and if it's not, you can immediately return false. But again, this kind of pattern of like going through an array, maybe short circuiting, but otherwise having like a default, that you'll see that more than once. But yeah, this super small solution, and I think it's correct, unless I have messed up like last time. Oh, I'm clicking the wrong buttons. Cool. So yeah, so you can see the test cases pass, and we can hit submit. I think my solution ends up being a little bit slower than most, but in like an interview, yeah, it's pretty slow. Some guy thought of some clever way to make it faster, but in an interview situation, like this is nice because it's not trying anything fancy. I could go back on it and make it better, but yeah, I'm not going to take that risk in an interview. Sure. So cool. That's the last question. There was an extra like bonus question, but that's like a medium difficulty, and we're already out of time, so I don't want to dive into that because it was a struggle for me. So yeah, so this is kind of like the end of our presentation or this session. I hope it's useful. Again, pretty low key, but yeah, thank you guys for joining. Hopefully this was worth your time. Yeah, hopefully have more such sessions in the future. So yeah.